Hey guys, welcome back to Click Academics. In today's video, I'm going to be showing you guys how to simplify radicals. So right here, we have the square root of 75, and we want to simplify this. Well, how would we do that? We're actually going to use a method known as prime factorization, and this is where we create a tree of factors. So let's try to simplify this radical. Well, our first step is to find a factor of 75 other than 1 and itself. So what's a factor of 75? It could be any factor besides 75 and 1. Well, I'm going to go with 5. And what times 5 equals 75? 15. So these two multiply to get 75, and they're both factors. And 5 is prime, so 5 is already finished. It doesn't have any factors other than 1 in itself. But 15 isn't prime because its factors are 5 and 3. And now we're done because the ends of our tree, the numbers at the ends, all are prime. And that's how you know when you're finished. And now we're actually going to rewrite this as the square root of 5 times 5 times 3. As you can see, these are the numbers at the ends of the trees. And now, well, what's 5 times 5? 25. The square root of 25 is 5. So we could just cancel these out and just write 5 here. And 3 is just left alone. It's still in the radical. It doesn't have anything to multiply with. So this is our radical in its simplified form. Now let's do this problem, radical 72. And I actually want you guys to try this out. So pause the video and try this problem out on your own. All right, so I'm assuming you guys tried this problem out. So remember, our first step is to find a factor of this number other than 1 in itself. And if you can't find any factors of a number, then that means it's simplified the most that it can. So a factor of this number, 72, is 8. And what times 8 equals 72? 9. And both of these numbers aren't prime because they have other factors. 8 has 4 and 2, and 9 has 3 and 3. And as you can see, 3 and 3, both these numbers are prime because they don't have any factors other than 1 in themselves. So this side of the tree is finished. Well, what about this? 4 actually has 2 and 2 as its factors. And now, as you can see, we're done because the numbers at the ends of the tree all have no other factors besides 1 in themselves, and they're all prime. So now we could rewrite this as the square root of 2 times 2 times 2 times 3 times 3. And whenever you have the same number multiplied twice in a radical, you could just make that number itself because 2 times 2 is 4. The square root of 4 is 2. Same goes with this. 3 times 3 is 9. The square root of 9 is 3. So you don't actually have to do much with that other than just write the number outside of the radical. And we're left alone with 2 inside the radical. 2 times 3 is 6 with radical 2 over here. So this is our simplified form of the radical 72.